Howdy. Recently, February 12th through 15th, I worked on creating zoetrope-like animations out of cut paper that created loops. In this video, I'm going to go over the concepts and process of creating the math, the programming that goes into creating those animated loops. And then later, in a future video, I'll talk more about the physical structure elements. The loops in these animations are all based on functions of trigonometry and some basic algebra. When dealing with loops in math, sine and cosine functions are an easy way to create smooth, consistent looping animation. Here's what a basic sine wave looks like. It goes from 0 to 1, back to 0, down to -1, and back to 0. The movement is not constant. It sort of slows down at the peak and then speeds back up and then slows down again, which gives for a nice sense of accelerated motion and ease when it comes to animation. Here we are in Cuttle. Cuttle is a parametric browser-based vector program that works well for CNC machines like Glowforge, Cricut, or any other machines that use vector files such as SVGs to communicate. Cuttle is free for limited non-commercial use. For full use, a subscription is required. This is the animation I am making a cut file for. It is a circle moving up and down inside of a rectangle. It's a simple loop, a good place to find your bearings and get acquainted with animating within Cuttle using trigonomic functions like sine and cosine to have accelerated motion. Here's that same animation in Cuttle playing back by manipulating the value of a parameter. If you look at this animation laid out sequentially left to right and exaggerate the frame height, you can very clearly see the sine wave that's formed by the animation. Here's a final cut file in Cuttle with all the stills and sequence laid out. Being able to generate this sort of cut file is where Cuttle really saves me a lot of time and effort. Now I will show how using sine in a formula can generate animation using Cuttle. In Cuttle you can create parameters and then put those parameters into formulas so that when you change the value of a parameter, it changes in every instance where that parameter is used. This is helpful for my animations when I want to increase the number of frames, change the size of an element, or similar things. Any instance of that parameter will update and I won't have to change every instance of that variable. It takes a bit of foundational work, but it makes things a lot easier later on. Let's make a circle move up and down. First, some groundwork. Cuttle has a structure where there are project files, and within those project files are components. Components can be embedded into other components, and any changes made to the original component will change universally throughout the project. The parameters that I mentioned earlier function similarly. There are two levels of parameters: project parameters and component parameters. Project parameters are consistent throughout the project. Component parameters are consistent within the component file, but if you embed a component, you can change the value of the parameter in that embedded instance. This becomes helpful for me when I want to make a cut file. I can change the parameter that determines where in the loop I want a frame to be. Like frame 1, 2, 3, 4, I can change what that is through the parameter. So let's start making a loop. First things first, when you open up Cuttle, you'll have untitled project. I'm going to name this animation loop, and you'll have a blank component file. On the right, you can see where the animation loop, the project parameters are, and then underneath it are the component parameters. I'm going to name this component frame, and that will update over here on the right. First things first, we're going to need a loop length, and for that I'm going to add a parameter in the project parameters section, and I'm going to name this frame num to indicate the total number of frames. In this case, I'm going to make 12. Next, I'll make two more parameters in the project parameters for the frame width and height. I'm going to make the frame width 3, and then frame height will be 2. These parameters are in the project parameters section because they will not change within the animation itself. Now I'll make some parameters that are animation specific. So I'm going to come down to the frame section, which is the component, add a new parameter. First, I'm going to add a parameter called time, which will represent where in the sequence of frames we are. I'm going to leave that at 0 for now. Next, I'm going to add another parameter. This will be circle diameter, and this will be the first time that I use an existing parameter to create a simple formula that will determine this parameter. I'm going to take frame width. You'll have a pop-up of parameters that you've set, and I'm going to divide this by 4. and now you can see frame width is 3 divided by 4 is 3/4 or 0.75. This means that if I ever change the frame width, it will adjust the circle diameter. So you can see that number underneath circle diameter changing. Let's see that actually happening in real time. I'm going to first come over to the shape section here on the left hand side and drag a rectangle over, and you have the rectangle pops up in the upper right, and you also have these variables down here on the lower right. So I'm going to change this position. The X is first and make that 0. Change the Y also to 0, and now it's at the origin point. And now I'm going to come down to scale, and for the width I'm going to adjust the X variable by putting in frame width, and then I'm going to come to the Y variable and put in frame height. Now we have a rectangle that has the frame width and the frame height. I'm going to drop this back down to 3. Now I'm going to pull in a circle, and now we have an additional shape listed over here on the top right, and the circle is selected, so we have the variables applied to the circle down here in the lower right. I'm going to put this again at the origin and change the scale, which it defaults to being square, where X is equal to Y because you want an even circle. I'm not going to mess with having it be oblong, so I'm just going to leave that as is and put in circle diameter, and now the circle has a diameter of 0.75. If I go into the project parameters up here and change the frame width, you can see that the circle adjusts in size as the frame width adjusts in size. Go back to 3. The next parameter that I'm going to add is going to be movement height. This will be used to control how high up and down the circle moves through our animation. This one will use a few existing parameters in order to determine its value. I want to take the frame height, subtract the circle diameter, and because we're dealing with sine and that value goes from -1 to 1, the difference between the maximum and minimum within sine is 2, so we're going to take the frame height minus the circle diameter and divide it by 2. We're going to come down to the circle, go to the Y and make it movement height, and now the circle is flush with the bottom of the rectangle. Just about to have some movement here. Now we're going to take the movement height and multiply it by sine. Sine in Cuttle is SIN, and then I'm going to put a left parenthesis, and with trigonometry in Cuttle it uses degrees, not radians, so a total loop is going to be 360 degrees, and we want to divide that by our frame number, which is 12, but we should use frame num, use the parameter and not use the actual number, because that way if we want to change frame number later on, we can just change it and it will affect this position. And now finally we need to multiply it by time. Close this parenthesis, and now we're ready to see some animation. Go to the time parameter, and if you click and drag on the numeric value, you can scrub through the animation. Because our frame number is 12, you start at 0, go down, then up, and it returns once you're back at 12. Anytime that you hit a multiple of 12, it will return back to its origin point. Having the circle actually hit the border of the rectangle isn't great for paper cutouts, so I'm going to add a border parameter. And I'm going to make this 0.25. And I'm going to come to movement height and subtract border. And now that's changed every instance of movement height, and so the circle will now only move to be 0.25 distance from the edge of the rectangle. Maybe this movement is too fast and you want to increase the total number of frames. All you got to do for that is come up to frame number and increase the number of frames. Now the speed is much slower. Maybe you want the frame to be taller. Just come to frame height, increase the height, and now if you play through, the circle adjusts to the new variables that you've put in. Maybe you want the width to be more narrow. decrease this, but now the circle's really small, so you come to circle diameter and change it to be, instead of 1/4, make it 1/2. And if you go to time and play through, you have a completely different, but still the same sort of movement animation happening. Everything adjusts accordingly when you have solid foundations and structure to your file. I'm going to reset everything. Just make this 12, 3, 2, and make this back to be 1/4. Reset the time. One last thing I'll do is embed this component into another component and dip our toes into modifiers and customizing repetitions. On the left hand side, you can see components over here. I'm going to add a new component. I'm going to make this cut file, and I'm going to drag frame over, and now I have an instance of the other component embedded into this one, and I can treat it as its own deal. I'm going to get the origin to be 0, 0. And now we have the frame within the cut file. If you select the component and then come up here to modify and go to drop down and do linear repeat, you'll have a bunch of different instances of this component on screen. By default, when you put on a linear repeat, it is displaced by 1 on the x-axis and has 6 repetitions. We want to change that. We want the displacement to be frame width, and we want the total number of repetitions to be frame num, which means that now we have 12 instances of this component that is flush on each edge. Below repetitions, you'll see customize each repetition. If you click this on, each instance of the repeated element now has a value tied to it, starting with 0 and going to whatever repetition number is set, -1, since 0 is a starting number. So each of these repetitions has a value of first 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The default name when you customize a repetition is going to be rep. I'm going to change this to frame rep. If you click a component that's embedded within another one, and you look below the project parameters, you'll see the value-based, not formula-based parameters that exist within that component. In this case, we have time and border. The frame rep parameter isn't being used by anything currently, so nothing visually has changed by clicking on this customize each repetition option. But now we're going to change the time to be a reflection of the number of frame, the repetition instance. So I'm going to take time and just name it frame rep. And now you can see the change in the position of the circle as it goes along these 12 instances. You can adjust all the parameters and see how everything adjusts accordingly. So if you increase or decrease the number of frames, the progression of the animation changes accordingly. If you change the frame width, it changes accordingly. Change the frame height. And you can sort of create your own animations in those forms. Now I will prep this for exporting an actual cut file. So I'm going to come into my frame, select both of these shapes, and with circle above rectangle, I'm going to come to modify and apply a Boolean difference, which means that whatever is in front will cut out of the shape behind it. And then I'm going to come to this group section and click fill, so you can more clearly see that if this is a cut file, this is a shape that is cut out. Here it is in that sequence where they're laid out left to right, but I'm going to be cutting this out of a piece of 8.5 by 11 paper. So I'm going to create a new component, call this cut file grid, and drag my frame in. And before where we applied a linear repeat, I'm going to apply a tile repeat. The default for Cuttle is displacement of 1 for one of the directions on the x-axis and the other one on the y, and 4 repetitions in either direction. I want to change the order of these because as these are set currently for the tile repetition, when I apply the customize each repetition, it'll go vertical to the bottom, then go to the next column and down. I prefer to have it go left to right and then go down. So I'm going to change this to be 0 for the first displacement and have the vertical displacement be frame height, and then come to displacement 2, make the X displacement be frame width, and the Y displacement be 0. And now we have a 4x4 grid, but I need 12. To get 12 frames, I'm going to now take the second repetition option and just make it 3. So now I have a 3x4 grid, and I'm going to customize each repetition, and I'm going to name this customized repetition variable cut rep. Still no change in the position of the circles. I'm going to click frame 2 here, go to the component parameters that are here, go to time, and change that variable to be cut rep. And now we have the position of the circle is a reflection of the formula that we entered in earlier, and this will be what I cut out of an 8.5 by 11 sheet of paper, and it clears that very nicely. You can adjust all the parameters to make an animation fit your needs. Since it's parametric, all the things we built will respond, and it is much easier than designing an animation frame by frame for anything that you need as a vector output. There's a lot more that can be done for specific needs and use instances, but this is a solid introduction into making loops using trigonometric functions in Cuttle for paper cutout animations. In part 2, I will go over some of the structures I made for the physical elements of things. Like and subscribe if you want to see more of this stuff. I stream Mondays through Thursdays at 3 p.m. Eastern Standard Time here on YouTube. Old streams are available to view in the live section of my channel. If you like the music played throughout this video, you can listen wherever you stream music. If you search for Trace Loops. If you want to support me on Patreon, you can do so by going to patreon.com/traceloops, where you will find high-res art files, older tutorials, any and all music I've made, available for download, and at the highest tier, you get a monthly piece of artwork from me in the mail. Thanks for watching. If you have questions, leave comments. I'll do my best to get to them in a timely fashion. And adios.